Ever pondered over how we know the Earth is round? In everyday life, we often take for granted the knowledge that our planet has a spherical shape. When you look out your window, the world may seem flat, but there's a wealth of evidence to the contrary. Today, we're going to delve into the fascinating realm of how we can prove the Earth's round shape through simple observations and experiments. You don't need to be a scientist or an explorer to determine the shape of our planet. All you need are some basic tools, a keen eye, and a sense of curiosity. And the best part, you can conduct these experiments anywhere, from an open meadow to a mountaintop. One of the most straightforward ways to observe the Earth's roundness is by observing the horizon. Stand at a high vantage point and look out. You'll notice that the horizon appears to curve slightly. This curvature is not a trick of the eye, but a result of the Earth's spherical shape. Then there's the beautiful phenomenon of sunrises and sunsets. Have you ever wondered why the sun appears to rise from below the horizon and set below it, creating a curved path? This is due to the Earth's rotation on its axis. Ever used a level to check if a surface is horizontal? If the Earth were flat, the level would remain flat everywhere. But due to the Earth's curvature, the level will show a slight deviation from being perfectly horizontal. If you live near a body of water, you may have noticed ships disappearing over the horizon. The bottom of the ships vanish first, followed by the rest of the ship. This happens because of the Earth's curvature. And finally, if you have access to a theodolite or a telescope, you can measure the angle of elevation of distant objects or celestial bodies. By comparing these measurements, you can ascertain that the Earth's surface is indeed curved. These methods all contribute to the undeniable truth. The Earth is not flat, but rather spherical. Join us in this intriguing journey as we unravel the truth about the Earth's shape. Imagine standing on a high vantage point, scanning the horizon. The cool breeze is brushing past you as you take in the expansive view, stretching out in all directions. You might be on top of a mountain, or perhaps in the middle of a wide open meadow. Regardless, you're here to observe the horizon, to look beyond what your eyes can immediately see, and to make a simple but profound discovery about our planet Earth. As you gaze at the horizon, you might notice something intriguing. The horizon isn't a straight line stretching out to infinity. Instead, it seems to have a slight curve to it. It's subtle, yes, but it's there. This gentle curve is an indication of something remarkable, the spherical shape of our planet. You see, if Earth were flat, we would expect the horizon to be a straight line, regardless of our viewing height. But that's not what we observe. The higher we ascend, the wider our view becomes, and the more the horizon appears to curve. This curvature is a direct result of the Earth's roundness. Let's delve a little deeper into this. Picture yourself on a beach watching a ship sailing towards the horizon. Initially, the ship seems to get smaller as it moves away, which is what we would expect due to perspective. But something more intriguing happens next. The ship doesn't just get smaller and smaller until it's a tiny speck on the horizon. Instead, it starts to disappear, bottom first, until eventually all you can see is the top of its mast, and then nothing at all. So what's happening here? Well, it's not that the ship is falling off the edge of the world, rather it's sailing over the curve of the Earth, gradually disappearing from our view. This phenomenon, known as the sinking ship effect, is another compelling evidence of Earth's curvature. Now you might wonder, if Earth is round, why don't we feel like we're on a giant ball? Why doesn't everything roll downhill? The answer lies in the immense size of our planet. Earth is so large that its curvature is barely noticeable at our human scale. It's a bit like standing on the surface of a giant beach ball. If the ball were big enough, it would feel flat under your feet, even though it's actually round. It's also worth noting that the Earth isn't a perfect sphere. It's an oblate spheroid, meaning it's slightly flattened at the poles and slightly bulging at the equator. But this deviation from a perfect sphere is very small, and for all practical purposes, we can consider Earth to be spherical. The concept of a round Earth isn't new. Ancient Greek philosophers like Pythagoras and Parmenides suggested the idea as early as the 6th century BC. Later, the Greek philosopher Eratosthenes even managed to estimate the Earth's circumference using simple observations and mathematics. In more recent times, astronauts in space have provided us with stunning images of our round blue planet. confirming beyond any doubt that Earth is indeed round. So there you have it. Just by observing the horizon from a high vantage point, you can gather evidence of Earth's round shape. It's a simple observation, yet it leads to a profound realization about our place in the universe. We live not on a flat plane, but on a massive, spinning ball, hurtling through the vast expanse of space. And the horizon with its subtle curve is a constant reminder of this incredible fact. So the gentle curve of the horizon is our first clue of Earth's round shape. It's a testament to the power of observation and the beauty of our spherical planet. The next time you find yourself standing at a high point, take a moment to observe the horizon. And remember, you're not just looking at the edge of your field of view. You're glimpsing the curvature of Earth itself. Ever notice the sun's path during a sunrise or a sunset? That's right, we're talking about that spectacular event in the sky that paints a beautiful palette of colors as the day begins and ends. The sun, our primary source of light and heat, appears to rise from below the horizon and set below it again, creating a distinct curved path. But have you ever stopped to think why it follows this path? The answer lies in the Earth's rotation on its axis. Imagine the Earth as an apple on a skewer. This skewer represents the Earth's axis. As the apple turns, different parts of it face the light source, which in our case is the sun. This rotation is what gives us day and night. But the story doesn't end here. This rotation also affects the path the sun seems to trace in our sky. Let's conduct a simple experiment. Choose a location. It could be your backyard, a local park, or even a mountaintop if you're feeling adventurous. Observe the sunrise and sunset from this same location on different days. You'll notice that the sun appears to rise from below the horizon, travels across the sky in an arc, and then sets below the horizon again. This path that the sun seems to take is not a straight line, but a curve. This is because while the sun is stationary relative to the Earth, our planet is rotating on its axis. As the Earth rotates, different parts of it come into the sunlight, making it seem as if the sun is moving across the sky. But wait, there's more. The height of the sun's path in the sky changes throughout the year. Ever noticed how the sun seems higher in the sky during summer and lower during winter? That's because the Earth's axis isn't straight up and down, it's tilted. This tilt, combined with our planet's orbit around the sun, causes the sun's apparent height in the sky to change with the seasons. So if you observe the sun's path throughout the year, you'll notice that it's not just a simple arc, but a series of arcs of varying heights. This series of arcs is called an analemma, and it's another piece of evidence that our Earth is round. You see, if the Earth were flat, the sun would have to move in a straight line across the sky, not in an arc. And the sun's path wouldn't change with the seasons. It would be the same every day. But that's not what we observe, is it? So next time you're enjoying a beautiful sunrise or sunset, remember, you're not just witnessing a stunning display of nature's beauty. You're also seeing evidence of our Earth's rotation and its spherical shape. But don't just take my word for it. Go out and observe for yourself. Watch the sun's path throughout the day and across the seasons. You'll soon see that the beauty of a sunrise or sunset is more than just a feast for the eyes. It's a testament to the round Earth we call home. Hence, the sun's curved path is another indication of our round Earth. Do you know a simple tool like a level can reveal a lot about Earth's shape? A level, you might know, is a tool commonly used in construction and DIY projects. It's designed to show whether a surface is perfectly horizontal or level. It's a pretty straightforward device, typically consisting of a small encapsulated glass tube filled with liquid and a tiny air bubble. The bubble, due to buoyancy, always rises to the highest point in the tube. When the bubble is precisely in the middle, it indicates the surface is level. But today we're not building a shelf or hanging a picture. We're using this everyday tool to prove something extraordinary, that the Earth is round. You might be wondering, how does a level do that? Well, let's get into it. To understand this, we need to delve a bit into the concept of level. When we say something is level, we mean it's parallel to the Earth's surface. But here's the catch. If the Earth is round, then the surface is curved, not flat. So a truly level surface would actually be a tiny part of that larger curve. Now, if you place a level on the ground, it should in theory align with that curve. The bubble should settle in the middle, indicating that the surface is level. But what if we move that level from one location to another? If the Earth was flat, the level would stay the same everywhere, right? But if the Earth is round, something different should happen. Because of the Earth's curvature, as we move the level, it should gradually deviate from being perfectly horizontal. It's a small deviation, but it's there. In fact, over large distances, this deviation becomes more noticeable. Engineers and architects have to take this into consideration when designing large-scale projects like bridges or railways. It's a phenomenon known as the curvature of the Earth. So while our level might seem to show a flat surface, it's actually aligning with the Earth's curve. And if we move it around, we can see that curve in the form of slight deviations from the horizontal. But there's more. The level not only shows us that the Earth is round, it also gives us a way to measure that roundness. By comparing the angle at which the level sits at different locations, we can calculate the rate of curvature. And guess what? Those measurements match up with what we'd expect for a sphere the size of Earth. Now keep in mind, this isn't a perfect method. There are a lot of factors that can affect the level's readings, like local topography and gravitational variations. But it's still a powerful demonstration of the principle at hand. It's pretty amazing, isn't it? A tool so simple, yet it can reveal something so profound about our world. That's the beauty of science. It's not always about high-tech equipment and complex equations. Sometimes it's about looking at everyday things in a new light and asking the right questions. So, the next time you're using a level to hang a picture or build a shelf, take a moment to appreciate it. This humble tool doesn't just help us with our DIY projects, it gives us a glimpse into the fundamental nature of our planet. It reminds us that we're living on a giant sphere spinning through space. So the humble level tool just provided us another proof of Earth's roundness. Ever observed a ship sailing away into the distance? It's a sight to behold, isn't it? The vessel gradually shrinking until it's just a tiny speck on the horizon, and then it vanishes. Poof. Just like that. But where does it go? Has it fallen off the edge of the world? Well, not quite. Let's dive into the science behind this fascinating occurrence. Picture this. You're standing on the shore watching a ship sail away. At first, you see the entire ship, the hull, the masts, the sails, everything. But as the ship sails further away, something intriguing happens. The bottom of the ship, the hull, begins to disappear, while the top, the masts and sails, remain visible. It's as if the ship is sinking into the sea, but you know that's not the case. What's happening here? This phenomenon is all due to the curvature of the Earth. Yes, you heard right. The Earth is not flat, my friends. Despite what some may claim, it is, in fact, a sphere. And this curvature is what causes the ship to appear as if it's disappearing bottom first. You see, as the ship moves away from you, it is essentially moving over the curve of the Earth, a bit like a car going over a hill. From your perspective, it appears as if the ship is sinking, but it's merely moving beyond your line of sight due to the Earth's curve. Let's take a moment to imagine a flat Earth. If the Earth were flat, you'd be able to see the ship in its entirety, regardless of the distance. It would just get smaller and smaller until it becomes a speck, but it would never disappear bottom first. The fact that the ship disappears bottom first is a clear indication of the Earth's spherical shape. Now you might be wondering, why does the bottom disappear first? Well, that's because the Earth's surface curves away from you. As the ship sails away, it starts to go down the curve, so to speak. The bottom of the ship, being closer to the Earth's surface, goes down this curve first and hence disappears from your view first. The top of the ship, being higher up, remains in your line of sight for a bit longer until it too goes down the curve and vanishes from sight. This ship observation is not a new discovery. In fact, it's been used for centuries as a means to prove the Earth's roundness. Ancient Greek philosopher Pythagoras was among the first to suggest a spherical Earth, and this was later supported by observations made by other Greek philosophers and mathematicians. And it's not just large ships that this applies to. You can observe this phenomenon with any object moving away from you over a large body of water. It could be a small boat, a jet ski, or even a person swimming away from you. The object will always appear to disappear bottom first due to the curvature of the Earth. So, the next time you're at the beach or standing on the deck of a ship, take a moment to watch a ship sail away into the distance. Observe as the hull disappears, followed by the lower sails, and finally the top of the masts. And remember, it's not magic, it's not an illusion, it's science. And it's beautiful. This simple observation, which anyone can make, provides compelling evidence of our Earth's curvature. It's a testament to the fact that science is not just confined to labs and textbooks. It's all around us, in every sunrise and sunset, in the shape of the horizon, in the level that shows a slight deviation, and yes, in the disappearing ships too. And voila! Another proof of Earth's spherical shape thanks to our ship observation. The Earth is round, my friends. And isn't it wonderful to have such simple and yet profound proofs of this fact at our disposal? So let's keep observing, keep questioning, and keep exploring this beautiful, round world of ours. Got a theodolite or a telescope? They're not just for stargazing. These fascinating instruments can be our allies in exploring the curvature of our planet. Let's delve into the details of how to use these instruments to measure the angle of elevation of distant objects and how these measurements indicate the Earth's curvature. First off, what is a theodolite? It's a precision optical instrument used to measure angles in the horizontal and vertical planes. Surveyors commonly use them to determine precise locations. Telescopes, on the other hand, are optical instruments that make distant objects appear magnified, allowing detailed exploration of the night sky. But how can these tools help us prove the Earth's roundness? The answer lies in the concept of the angle of elevation. This angle is the angle between the line from an observer to an object and a line from the observer horizontally. Theodolites and telescopes are perfect for measuring this angle accurately. If you're using a theodolite, you'll need to set it up on a tripod, making sure it's perfectly level. Then look through the eyepiece and aim it at a distant object, like a tall building or a mountain peak. Once you've got the object in your sights, you can read off the angle of elevation on the scale. Using a telescope is a bit different. You'll need to align it with a star or celestial body and record the angle. You can do this by noting the time when the celestial body crosses the meridian, an imaginary line that passes through the north and south poles in your location. The angle at this moment is the angle of elevation. Now, if the Earth were flat, the angle of elevation to the same object would be the same no matter where you are. But if you take these measurements from two different locations, you'll find that the angles are different. This discrepancy can only be explained by the Earth's curvature. Let's consider an example. Imagine you are observing a star from two different locations on Earth. At location A, the angle of elevation to the star is 60 degrees. At location B, some distance away, the angle is only 45 degrees. This difference in angles is a direct result of the curvature of the Earth. If the Earth were flat, the angles would be identical. It's also worth noting that the further apart the locations, the more noticeable the difference in angles. This is why explorers and scientists in the past often made these measurements over large distances. The larger the distance, the more pronounced the effect of the Earth's curvature on the measurements. But what if you don't have a theodolite or a telescope? Don't worry, you can still observe this phenomenon. Next time you're on a flight, look out the window as the plane climbs. Notice how the horizon drops away. That's the Earth's curvature in action. In conclusion, theodolites and telescopes are more than just tools for surveyors or astronomers. They're instruments that can help us understand the world around us, revealing the truth about our planet's shape. By measuring the angle of elevation of distant objects from different locations, we can see the curvature of the Earth. And there you have it. Yet another testament to our round Earth, courtesy of our friendly theodolite or telescope. So how about that? Simple observations and experiments leading us to a profound truth. From the vast expanse of a meadow or the lofty heights of a mountaintop, we've journeyed together to demonstrate the roundness of our Earth. Just as scientists and explorers of yore, we've used nothing but our senses and a few simple tools to engage with the world around us. First, we turned our gaze to the horizon, that boundary between land or sea and the sky. From our high vantage point, we observed it stretching out in all directions, gently curving away from us. This curve, subtle yet undeniable, speaks volumes about the Earth's spherical shape. Next, we watched the sun as it rose and set, creating a mesmerizing spectacle of light and color. But did you notice the path it traced across the sky? Rising from below the horizon, arching high overhead and then setting again below the horizon, The sun's journey is a clear indication of the Earth's rotation on its axis. We then brought out a humble yet powerful tool, a level. If the Earth were flat, this tool would remain perfectly horizontal no matter where we placed it. But just as we suspected, the level showed a slight deviation, a testament to the Earth's curvature. Remember those ships we watched sailing away into the distance? As they moved farther away, the bottom of the ships began to vanish, followed by the rest of the ship. This captivating phenomenon is yet another testament to the curvature of the Earth as the ships journey over the horizon. Finally, we turn to a more advanced tool, a theodolite or a telescope. By measuring the angle of elevation of distant objects or celestial bodies and comparing these measurements from different locations, we were able to deduce the Earth's curved surface. These methods may seem simple, but don't let that fool you. They are time-tested techniques that have been used by scientists and explorers over centuries to prove the Earth's round shape. From the ancient Greek philosopher Pythagoras, who was one of the first to propose a spherical Earth, to the modern astronomers studying distant galaxies, these methods have been instrumental in our understanding of our planet. We live in a world of complexity and mystery, but sometimes the most profound truths are right under our noses, waiting to be discovered. All it takes is a keen eye, a curious mind, and a willingness to engage with the world around us. So next time you find yourself standing in an open meadow or atop a mountain, take a moment to observe. Look at the horizon, watch the sun's path, see how the ships disappear, and if you can, measure the angles. The world is full of wonder and you have the tools to uncover it. The Earth is round, and with these methods, you've just proven it yourself.